So just like alcohols can be oxidized to form aldehydes and ketones can be reduced to form alcohols. So whereas oxidation is the forming of more carbon-oxygen bonds or losing carbon-hydrogen bonds, reduction is losing carbon-oxygen bonds and or forming carbon-hydrogen bonds. So if we look at an aldehyde or ketone that has this characteristic double bond between the carbon and the oxygen, when an aldehyde or ketone is reduced, it loses one of those carbon-oxygen bonds and it gains a carbon-hydrogen bond to form an alcohol. And of course, this carbonyl oxygen also gains a hydrogen to form an alcohol. So aldehydes are going to be reduced to form primary alcohols, where that hydroxyl group is at the end of the chain, and ketones are going to be reduced to form secondary alcohols. So let's look at worked example 15.2, and what product would you obtain by the reduction of benzaldehyde? So pause the video and see what you get. So the first thing you want to do is you want to write out the structure of benzaldehyde. And then what you want to do is you want to take this bond right here between the carbon and the oxygen, and you want to bring it up here. So the oxygen still has two bonds, but they're not both bonded to the carbon. And then you also want to draw a bond to the carbon, because now that it's lost that double bond, it still needs 4 bonds. So now carbon has all single bonds, and the oxygen still has 2. And then where those bonds are that you've drawn, you put hydrogen. So we have a primary alcohol here. This alcohol group is bonded to a carbon that has 2 hydrogen, and we get benzyl alcohol. So if you got that, give yourself a pat on the back.